Hello and welcome back once again. In the last video, we talked about model training. So we were able to train our LGBM classifier model on the training data. And after that, we were able to track our experiment using MLFlow. So that was the main thing that we discussed during the previous session on the model training part. So today we will be handling the model evaluation. So after training the model, then we need to evaluate the model on a new set or a new set of data. So today we are going to start with the model evaluation. So under model evaluation, we'll be doing a couple of things. One of them is just about evaluation, model evaluation. Then we will be plotting some charts. That is the ROC curve, the receiver operating characteristics curve. So we'll plot that. We'll also plot a precision recall curve. Then we'll also save the metrics data, including the accuracy, F1, precision, and all that. And all that information we'll be tracking again using MLFlow. So sit tight as I show you how we can achieve that. And once again, I'm Western Onzere, and this is Minic Analytics, where we show you how to build, deploy, and monitor your machine learning and AI systems in production. Subscribe to the channel if you haven't. Like this video, and let's get started. So let's jump to the model evaluation. I don't think we do need this. So let's start with the model evaluation part. Okay, we're just picking up from where we left during the last session. So this is just a continuation of what we did previously. So under model evaluation, as usual, we're going to start by importing the libraries that we need in this experiment. So let me import those libraries. So as usual, these are the. So now I think you understand or you can comprehend what we are doing. So this is just the libraries that will be necessary for this model evaluation. Then I'm also importing the MLFlow and all this so that we are able to track our experiments. So I'm going to develop or start with the model. It's not model trainer, model evaluation. So this is the model evaluation config. So we start with that. Then under this, we need to set up the necessary files under the config.yaml. So we specify the parameters. So this is the model evaluation step. So again, we create a root directory for model evaluation. Then under this, we'll be passing in the, don't know if the test data is the correct name here, but test data path, target variable path. So as you can see, this is the xval, this is the yval that we are using here. And the model path, the metrics file name, because we'll be saving some metrics. Then the MLFlow URI. So these are just the same things. If you have been following through, you can watch the model train, and you will kind of get a clue of what are these. These are just the hyperparameters, not hyperparameters. These are the parameters for us that will be useful or that we will be using during the model evaluation. So let's jump back into the model evaluation. So trial model evaluation. So under the config, we need to specify under the config. Then we need to recall those and specify that under the config, so that the root directory, test data, test targets, model path, all params, metric file path, target column, and the MLFlow URI. Then after that, we need to set up our configuration manager. So this is the configuration manager. Then the configuration manager, this is the get model evaluation config. So it will be reading the different files from the config params and the schema. Then we'll return the model evaluation config. So essentially, it's not we are not changing much from the previous video. It's just something a little bit of things. Essentially, this one most of the task was happened during the model trainer, but this is just the model evaluation where we just sort of import the necessary data, then validate the model itself. So also include some other these are the other files or libraries that will be necessary for this. So I'm just going to save this. Okay, I think that one is good to go. So after this, we create the model evaluation class that will actually handle the model evaluation. So let's create that class. So it's supposed to be class model evaluation. For the model evaluation, def init self config model evaluation config. Then you can say self config. So that one is okay. Then the next step is about making the predictions. So def I'm creating a new method. So this method will be for the predictions. So predictions. And I'll specify here we'll be using calling the model, and also we'll be using the X validation data. So xval transformed, transformed. Then after this, we can call the ypred. So ypred model.predict. So we'll be predicting that on the validation data. Then the ypred prober, because we will be plotting the roc curve as well as the pr curve. So for us to plot that, we'll be using the ypred probabilities. Okay, then they return the ypred and the yprober. Then after this, we need to now do the model evaluation. So def. So I'm creating a new method. So this will be the model evaluation. This will be the model evaluation. So this will be the yval, ypred, and the yprober. This one here. So under this, we'll be specifying the different evaluation metrics. So evaluation metrics. So accuracy, I will be doing that. The precision score again will be for the precision. Let's use the weighted instead of macro. Weighted. Then for the recall again, instead of macro, let's use weighted one. The weighted to factor for or cater for class imbalance. So let's just prefer to use the weighted. So I think that one is good. So the receiver operating characteristic as well as the PR curve. So then after this, I can then print print the classification reports and the confusion matrix, and print those. And yeah, and from here we can return the accuracy, and also return the precision, also return the recall, can also return the F1, the roc AUC, as well as the pr-auc. AUC is just area under the cover. Then now we can plot those different charts. So for example, let's start with this one should be, so we can start plot the receiver operating characteristics curves. So we first binarize the output because we are dealing with multi-classification. So we first need to binarize our output so that it's considered something like a binary classification. Okay, so we need to, so with the binarize the labels, you can see binarize labels in a one versus all fashion. So you can just read through and see several regression binary are available. So a simple way to extend these algorithms to a multi-class classification case is to use the so-called one versus all scheme. This function makes it possible to compute this transformation for all fixed sets of class labels known ahead of time. Okay, so you can just read through and you can see how it handles that. Okay, so that's it. Then false positive rate, true positive rate, then the dictionary receiver operating characteristic roc-auc curve, and this is just plotting that. Then we plot the curve. This is just the using matplotlib to plot the curve, labels, and all that. So after that, then we need to also plot the precision recall. So for my case, I just like using as much using the many. I like using the many evaluation metrics as possible, so that I make my code to be scalable. So it might reach a time when you have a lot of class imbalance is a factor in your evaluation. So that's when maybe the precision recall curve will be necessary. So instead of now, when that time comes, you already have it. So you are able to vary between the precision recall curve and the receiver operating characteristic curve, or if you have other metrics like the accuracy, precision, the recall. So I'm able to track as much of these metrics so that to make the code scalable. And then after that, we can then save the results as well as these plots. So I'm just going to save the results. So I'm saving the accuracy, precision, recall, F1 score, roc, and PR curves. So you can self.model evaluation, ypred, yval, ypred, prober. Then we save those in terms of a JSON file. So remember we created that JSON file here, so model evaluation. We can call this as evaluation evaluation metrics.json. Yeah, you can call it that. So we can just save this. So this will plot the roc curve, and this will be plotting the precision. Then we log the metrics. Then after logging the metrics, then that's where MLFlow comes in. So we need to track this metrics. So log metrics in MLFlow. So these are the metrics that we are tracking. Log the parameters. So parameters, I think these are the hyperparameters. We also logging those during the model evaluation. And to add on that, we also tracking this artifact, the roc and the PR curve. So once we are done with that, then we can create the last block, the main block. So let me try to minimize and see if we have everything. Make sure that these methods are in line to prevent us from getting some errors. So I think everything is okay up to this point. Are we missing anything? I don't think so. Let's execute this. Let's execute this. So that is the model evaluation. So I'll just call it Python model evaluation. So I'll just copy relative path. Then you can just do this. Before we run, make sure you have saved everything. So the model evaluation, again, just to take you through. So we are evaluating the model using a new set of data. So we first start by inputting the necessary libraries. We'll be tracking this with the MLFlow. So we create a model evaluation config entity. Then we create a configuration manager that is going to create the necessary directories and read these YAML files and extract that information from those paths that we have specified in the model evaluation config entity. And after that, we create the class model evaluation class, and this will be the class that will actually handle the evaluation part, because you can see we are making the predictions, and then after this we are doing the model evaluation. So this is the class that actually does the model evaluation part. Then after that, we are plotting some charts, the receiver operating characteristic, the PR curve, the precision recall curve. And as I said earlier, is that I like tracking at least all of these evaluation metrics so that you make your code scalable. Then after that, we use MLFlow. So you can see MLFlow is just a small distinct. And for the MLFlow, you can see we're just tracking the different. So you can see for this one, we are run name is the model evaluation. Then now you can see we are tracking the accuracy, precision, recall, F1 score, the roc AUC, the PR curve. And now we're also tracking the different curves for that, so that despite us just tracking the value itself, we're also tracking those charts. Okay, then we create the main block. Then after this, I think everything is quite okay. Then we can just execute this in our terminal. As you can see, as we progress into the model evaluation, again, model validation just looks the same as the model evaluation. It's not something different. This we are just evaluating the trained model. Then we need to evaluate the model now with unseen data. So that's why we use the validation part. Most of the time, you'll find that mostly just do a train test split. They don't reach the evaluation part. But for me, I like doing the comprehensive part of that. Okay. So as no attribute predictions. So we are getting some error. Model evaluation has no attributes predictions. Supposed to be predictions, but we have here used a prediction instead of predictions. So these errors, sometimes they are testing. Sometimes it's good to encounter this error so that they sharpen your skill. So I'm just going to run this again. It was just a small issue with the prediction. See this one here. So instead of predictions, I used prediction. That's why we were encountering this error. But I don't think I think it will run successful. So once again, when this is complete, we'll go to our Dagshub, and from there you will see the model experiment, and we'll see how the model is working. So I think you can see created the artifacts, and we are getting some error here. Multi-class must be in OVO or OVR. Model trainer, model evaluation, model where let's see. Artifacts, model evaluation, 205, 202, 202, 207. Recall. 82 see why versus rest classifier. Supposed to use this one. Multi-class. No, let's try this again. Just save this. Average predicted, yeah. Accuracy, y-val, y-pred, this one is okay. Precision, y-val, y-pred, average weighted. Supposed to be the multi-class, this one here. I think we were missing this in the previous one. So we just include this multi-class OVR. Supposed to be OVR, this one here. One versus rest, I think so. One versus the rest. Yeah. I think that's what we were missing, I think so, in the last. That's why we are getting that error. Let's see. So we are running this again. Yeah, I think now it's okay. So the challenge was coming. We were excluding this. That's why we are getting that error. So you can see this the training. So this is the training part. Precision recall F1 score support. This is how our model is performing, and this is the confusion matrix. So this is the evaluation matrix.json. So let's go to our experiments, Chanpred, and from here we expect to see the experiment. This is the latest one that we have done a few seconds ago. Model evaluation. So you can see these are the values for the accuracy, F1 score, pr-auc, precision, and the recall. These are the parameters. We're also tracking the parameters during the model evaluation. And you can see the accuracy, F1 score, the different charts. So for the artifacts, these are the two artifacts that we were tracking. So the PR curve, you can see this is the precision recall. So you can see how for the different classes. Class 0, we are it's quite performing least compared to class 1 and 2. And the roc curve, you can see class 1 is doing better. Class 2, 0.97, 0.92 for class 1. Because we don't have a lot of class imbalance, I think the roc curve can be serve us better. Because I don't think we have a significant class imbalance. So that's it. That's how we track our model. The model trainer, model evaluation. So once this is done, then the next obvious step is to group this into the respective elements. So we start with the entity. So config entity, we go to our entity, config entity, and we just yeah. So entity, that one is done. Now we go to the model evaluation. Nope, the class. We go to model evaluation. Get model evaluation. So we update our configuration. So the configuration model evaluation. So this one here. That one is good to go. And after that, we need to update. Also need to update our model evaluation. So we need to update the config or the components. So model evaluation component. So model evaluation. So I'll just copy. Then I'll paste it here. Then this is the pipeline. Don't need this one here. This one is okay. We don't need also the configuration manager, as well as the config entity. Config manager, don't need this, the config entity. This might remain. Save JSON. You can just do away with what is unnecessary. For the model evaluation, again, we need to import model evaluation config from config entity. This one here, so that we solve for this error. Another thing, so let's just cross check. I don't think we are leaving anything out. I think that one is okay. I think that one is, yep. So after that, we need to update the pipeline. So model evaluation pipeline. The pipeline, we can just update that. So model evaluation config manager. So that is it. So we just give it the name of the pipeline, model evaluation pipeline, and everything is set. Then after that, the last thing that we need to do is to update the main.py. The main.py, we are updating the model evaluation. So model evaluation in the main.py. So this is the model trainer. Below it, include the model evaluation component. And after that, we need to update the dvc.yaml, so model training. And now we also need to update model evaluation. So for the model evaluation command, that is the Python pip5 model evaluation, we need to be sure. Then the dependencies pip5 model, config.yaml. Then the outs for this. Let's check. So for the artifacts model evaluation, we do have the roc-auc png, this one here. Make it sure that everything is okay. So the roc-auc png. Then we do have the pr-auc. We need to track all these artifacts. Then we do have the metrics.json. No, I don't think this one. Metric.json. Metrics.json. I think that one is okay. JSON. Yeah. So what I'll just I think we have updated it, so I can just run the dvc repro so that we can track this pipeline. Then after that, we can save, we can push this code to the Git. So also in the dvc.yaml, you're able to track your, these are the different components of the stages. We have the data ingestion, validation, data transformation, model training, and the model evaluation. So this will be found under the dvc.yaml. Okay, so dvc.yaml, model trainer.joblib. So this we can say works simultaneously or in the same way then with the main.yaml. Okay, so let's execute that and track the pipelines. See, it's running the stage data ingestion. So that's it. So you can see we used the dvc.yaml, and then we were able to run again from the beginning until the model evaluation pipeline. You can see terminated successful. Then it's just updating the dvc lock. Then you can see updating the dvc lock file. So that's it. So that's all about the model evaluation. So I think we can commit and push this to git. So just do a git add, just do git commit. Then here we can just say we are committing the model evaluation. So we can say model evaluation commit. Then after this, git add, git commit, so git push -u origin. So that's it. So I think you now have it. You have it. Just clone the GitHub and you'll have all this. So that's it. That's it with the model evaluation. So this was just something small relative to model training. So, model training was the chunk of this, but for the model evaluation, it was just something small. Okay. So the next thing will be model validation. I think that will be the last thing. And from there, we will develop a web application using Streamlit as well as the Flask. Then we'll also link this with the email. We'll also link this with an email. We just use an API to create some sort of an email messaging system, such that we'll be sending messages to different clients based on their churn score. Okay, so that will be dealing with that during the app development. Then I will also connect the results. We'll create a new database with a new. We'll create a new database that will store the predictions, and then from there we can then use some tools like Power BI, so that we can create dashboards after the predictions and after making predictions and saving those models. After saving those predictions, then we can make something like dashboards using the Power BI and all that. So you will see when we reach that. So that's it. That's it for today. Once again, I'm very grateful for you finding time to watch these videos. As usual, please consider subscribing to this channel if you haven't. Like this video on your way out, and let's meet in the next session where we discuss about model validation. So, and just before we close, there's something maybe we can show you. There's something. If you go to our files, let's see if we have included. Where is the DAG? This one is the data pipelines. Let's try to visualize these pipelines. So after including the data transformation, you can now see the outlook of that. So with the config.yaml, you can see it's after the data validation, and the transformation. You can now see the transformation. You can see the model training and the different artifacts that so for the data transformation, you can see these are the different artifacts from that. Model training, you can see we only have one artifact, which is the model itself. The model validation, you can see we have the PR, the PNG, the PR curve, the roc curve. Then yeah. So that's it. So this is you can visualize the pipelines here. So that's it. That's it for today. Let's meet in the next session when we talk about data validation. See you in the next one. Have a nice day. Goodbye.